We all want our tech to be better, right? Faster, stronger, more efficient. From our phones to our cars, there's this constant push to get more performance out of everything. But here's the thing. The good old silicon that's powered our world for decades, it's kind of hitting a wall. It's running out of steam. So what's the next big thing? Well, let's talk about the material that's about to change, well, everything. And here it is. This is silicon carbide, or SiC for short. The easiest way to think about it is like silicon's superpowered cousin. It can handle way more heat, it can manage much higher voltages, and it can switch on and off faster than you can blink. And I mean, this isn't just a small step up. We're talking about a genuine game changer for the entire future of electronics. So, how are we taking this incredible material and actually putting it to work? We're going to see how a company called SiC Semiconductor is really leading the charge. We'll kick things off with the big picture, then zoom right in on their cutting-edge MOSFETs. After that, we'll explore their whole range of products, and finally, see how it all performs out in the real world. All right, so we've got this amazing raw material, silicon carbide, and it's just packed with potential. But that's really just the beginning of the story. The real trick, the magic, is in turning these shiny wafers into actual usable components that engineers can build with. So how do you do that? How do you unlock that potential and get it into the technology that powers our lives? That is the million-dollar question. And that's exactly where SiC Semiconductor enters the picture. They specialize in making these crucial parts, and they really focus on three key areas. First, you've got your workhorse SiC MOSFETs. Then there are the super-efficient SiC Schottky barrier diodes, or SBDs. And finally, some really clever hybrid devices that actually give you the best of both worlds. Okay, let's start with their flagship product line, the third-generation SiC MOSFET, which they call the B3M series. This is where things get really, really interesting. Now, before we dive into the specs, there's one key term you gotta know: figure of merit, or FOM. Just think of it like a golf score for a transistor. The lower the number, the better it is. A low FOM means less energy is wasted as heat every time it switches. And in the world of power electronics, that is a very, very good thing. 30%. A 30% reduction in that figure of merit. Let that sink in for a second. That's not a tiny improvement. That's a massive leap forward for power electronics. Seriously, this is the kind of breakthrough that engineers dream about. It opens up totally new possibilities for what you can design. So what does a 30% lower FOM actually mean for the folks designing things? Well, it means less energy is wasted, which means less heat to get rid of. And that means you can use smaller heat sinks, which lets you build products that are more compact and way more efficient. Think about an electric car that can charge faster, or a data center that needs a lot less power just for cooling. That's the kind of thing this enables. It's a win-win-win. And it's not just about making a fantastic chip. You have to make it easy for designers to actually use it. So SiC offers their B3M series in all sorts of different packages. You've got these beefy through-hole components for really high-power applications, and then you've got these tiny surface mount versions for more compact designs. It's all about giving engineers that maximum design flexibility. But look, powerful MOSFETs are only one piece of the puzzle. A modern power circuit is like a team, and it needs a full lineup of components all working together. So let's see what else SiC brings to the table. So, meet the SiC Schottky barrier diode, the SBD. These things are the perfect sidekick for SiC MOSFETs. They're incredibly fast, they're super efficient, and they basically act as a one-way street for electrical current, making sure as little energy as possible gets lost in the process. Okay, now this is a really smart move. Instead of forcing everyone to go all in on SiC also offers these hybrid devices. What they do is take a proven, cost-effective silicon IGBT and pair it with one of their high-performance SiC SBDs. But why would they do that? Well, it's all about getting the biggest bang for your buck. You see, by just swapping out the old, slow silicon diode with a super-fast SiC SBD, you can give an existing design a huge performance boost without having to do a complete and probably expensive overhaul. It's kind of like putting a turbocharger on an engine you already know and trust. It's a clever upgrade. All right, so theory and specs are great, but the real proof is in the pudding, right? The real test is how these things actually perform out in the wild. So let's look at a pretty demanding application, a high-power solar inverter, and see these benefits come to life. This is where the rubber really meets the road. We're talking about a 320 kilowatt solar inverter. This is a serious workhorse in the renewable energy world, and it has to run reliably day in and day out for decades. And if you look right at the heart of its design, in the most critical parts of the circuit, you'll find basic SiC components working together. And the results, they really do speak for themselves. By using SiC, the designers were able to use smaller magnetic parts, which makes the whole inverter smaller and cheaper to build. It's also more efficient, which means more of that precious solar energy actually makes it to the grid. It just clearly shows you the power of this technology. Let's look at some cold, hard numbers. This table puts BASC's latest MOSFET head-to-head with some of the biggest names in the industry. The first thing you'll probably notice is that generation row. You can see BASC is a G3, or third-gen device, putting them right at the cutting edge. And when you look at the actual performance specs, you see they aren't just keeping up, they're a leader. Performance is one thing, but in these high-power systems, reliability is absolutely everything. BASIC builds their reputation on 3 key pillars. First, ensuring a high breakdown voltage, which gives you a big safety margin. Second, keeping leakage current incredibly low so you're not wasting power. And third, maintaining really high consistency from one chip to the next so you know exactly what you're getting every time. So at the end of the day, what's the big takeaway here? It's that BASIC is providing the essential tools that engineers need to build the next generation of power electronics. With their SiC devices, we can create systems that are smaller, faster, more reliable, and more efficient than ever before. This technology is already shaking up huge industries like electric vehicles and renewable energy. But as it gets even better and the costs continue to come down, you have to wonder, what's next? What industry is going to be completely revolutionized by the power of silicon carbide?